Hello and welcome to today's webcast, Data Summary and Analysis. My name is Mia Stevens and I am your host for today's presentation. We'd like to answer questions that arise during the broadcast, so please use the chat or the Q&A panels to submit your questions. However, we'll try to wait until Julian completes his presentation to address your questions. So let's meet our presenter. Julian Paris is an academic ambassador with JMP, which is a business unit of SAS that specializes in desktop software for dynamic data visualization and analysis. So with that, we invite you to sit back and relax. And Julian, I'll go ahead and turn it over to you.
Fantastic. All right, and I'll share my desktop. So Mia, can you confirm you're seeing my desktop here?
I can see your desktop.
Perfect. Well, great. Thanks for the introduction, Mia. And thank you, everyone, for joining us for this webinar. These are always fun webinars to give, and I like to give a little bit of a context of where this one sits really within our whole webinar series that we do here on the academic team. And so this one's called Data Summary and Analysis, and I like to think of it as almost like the second or third webinar we hope you've seen. Certainly, if you've never seen JMP before, don't worry. You're going to see lots of neat things in JMP, and we'll make sure that you have all the basics covered. But if you have seen JMP before, I certainly want to make sure you see some of the more advanced things you can do, and you leave this webinar knowing new ways to be efficient and to get the most out of your data with JMP. So with that, let me give you a little bit of an idea of what I want to cover today, and then we'll get right into content. I'll start showing you some neat things. And so today we're going to break apart really summary and analysis into separate sections. And so with summary, I want to cover distribution, a really great platform in JMP, and really a good idea about how to understand your data from the very get-go. We'll talk about tabulation, and we'll talk about graphing. Not something we typically think about as summary, but really a graphic is really a visual summarization of whatever the meaning is in your data. So we'll do summary first, and then in analysis, I want to talk about three really big groups of analyses: regression type analyses, so that could be simple or multiple regression; tests of means, so that could be an analysis of variance, that could be a t-test; and I just want to talk about contingency analyses, so things like chi-square tests. I always like to mention some of the really basic and special tools in JMP, and so we'll go through some of these, not as separate topics, but really as we're going through other bits of today's webinar. So formulas, bivariables, switching columns, some of these really expand the use of JMP. And then finally, I always like to finish, and actually I always like to start with a talk about resources. So I'm going to point you there right now, just so you can get an idea of really what's out there, and so you know what you really should and shouldn't pay attention to in this webinar. Certainly pay attention to everything, but know that you have a lot more opportunities to get certain types of resources. So with that, let me just pop over to the academic community. Here's what it looks like. And I want to just drive your attention right to the left right away, so the top resources, because there's one that I want to point you to, which is the recent academic webinars. So I'm recording this webinar, so after today and after I encode it, it'll appear right on this page. So certainly as you watch today, don't feel like you have to write everything down or try it all right away while I'm doing it. You can sit back and watch and know that there'll be a recording of this webinar you can go back to see exactly the things I did again. And so that's a great place to know that's on the community. And there's some other great resources here. So the collection of one-page guides is one I'll point you to. And then we'll come back to this at the end and look a little more in detail. But just so you know, if you're interested in very procedurally focused guides for JMP, so how do I assess normality of a distribution, or how do I make a scatter plot? Each of these sections has a video as well as a one-page PDF you can download. And so if you're looking for procedural-based information in JMP, this is a great place to go. All right, so we'll come back to resources at the end. Just know what's available out there. And think of today's webinar as not only showing you how to do the things we're going to do in JMP, but really why we're going to do them and the process of doing them. Many of you, if you've used JMP a lot, know that one of the magical things about JMP is how quick you can get at doing things once you get in flow. And so we're going to make sure that you leave today knowing exactly how to get into that sense of flow with JMP. So let's start it off with summary. And to motivate this section, let's think about summary as really what you're first doing when you get to a data set. You may just want some basic descriptive statistics. You want to know what type of data you've really measured, and you want to get a sense of it before you jump into analysis. And this is always a very sensible thing to do. And so let's start with understanding the distribution of a variable. And if you haven't heard that word in a while, what I mean here is really what types of observations did we have within a particular column or a variable in our data set. And so to start this, let's actually get a data set. And I'm going to click on the sample data link. And so this will actually bring up a sample data set we use in JMP called consumer preferences. If you've never seen actually the consumer preferences or a sample data set in your JMP under help, you can get to the sample data by going to the sample data section. And this is something I suggest you do when you're first learning JMP. Go to the help menu, open up sample data, and just get familiarized with this listing. So they're listed by types of analyses, and these little gray triangles, they're little disclosure buttons. They'll show you more if you click them. And so you can actually go through and look at different types of data. This is a great thing to do as you're learning JMP. If you want to follow along with this video later on, click the Open Sample Data Directory section and navigate to Consumer Preferences. And so you'll have this file on your desktop. All right, so let's go back to my little schedule here. So distribution, again, what I mean by that is understanding each variable really one at a time. And if we look in our data set, consumer preferences has a lot of kind of interesting data. These are for 448 individuals. Responses really to what would be a survey about sort of general preferences and things people do. So we have some numeric data, things like birth year, what their age is, the number of years they've been at their current employer. Those are kind of interesting. And we have some qualitative variables or categorical variables, what their employee tenure is, so converted into categories, or things like job satisfaction. Are they satisfied or not? So each one of these is a different variable. And if we want to understand across all the individuals what we've observed, that's distributional analysis. And in JMP, the best place to start is under Analyze, Distribution. So let's go there now. And so the Analyze menu, if you haven't seen it before, in JMP holds what are called platforms. And platforms we like to think of as really big, overarching groups of analyses, almost like rooms in a house. A room in a house doesn't hold just one thing. It holds lots of related things. And so in JMP, a platform holds related analyses. So let's go to the distribution platform. And what JMP shows us first is what's called a launch window. It's asking us which columns we wish to bring along with us to the interface we're about to get to. And so let's actually take a few. And this is something I would suggest you do with every new data set you get. Take a group of columns, or actually every column, is my suggestion. As soon as you get the data set, click them into the Y role. So that's adding them to this list here. Because what you're going to do by using the distribution platform is get a great overall sense of the data you've observed. And this is a great first step because you'll identify outliers if they're there, so observations that don't make sense given the rest of the data. And you'll also identify in variables like single status or school-age children whether you've miscoded anything. So you may see often people put N's and no's in the same data set. So those will be recognized as different levels if the spelling is different or the capitalization is different. The distribution platform in JMP is a great place to find those errors before you do analysis. All right, so let's just take a sense to look at the distribution platform if you've never seen it before. One thing that's striking to most people is that our histograms are vertical in JMP. This is the default setting in JMP. And part of the reason why is our screens are wider than they are tall. And it's nice to be able to look across and see a lot of output all at once. Another reason that's valuable in JMP is that these histograms or these distributions, they're not static. So these are all little interfaces. These are active graphs in JMP. What I mean by that is let me click a bar. I'll click the single individuals. And all the individuals who are in that bar, who are single individuals, those rows in the data set are actually now highlighted. And in every other graph, notice that the observations are shaded. And so the distribution platform gives you a way to click through and sort of profile relationships. We're not testing anything here. We're simply clicking to see where observations are. But it gives us, again, a sense of the data. And when we think about summarization, that's what I think we're doing. We're trying to get a sense of our data, at least from the outset. All right, so just a couple important things about the distribution platform. Certainly, we're using it as a way to summarize, and we see that we have summary statistics under each of our numeric columns. And under our categorical columns, like gender or single status, we have frequencies. And so this is something I hope you've noticed about JMP. JMP is smart enough to know what types of summary statistics to give you for each type of variable you provide. So categorical variables get a different type of output than continuous variables or variables that are numeric. And just to remind you, if you aren't a JMP user yet, or if you haven't used it much, that the way JMP is knowing what type of output to give you is based on the little icons over here, which reflect the modeling type of a variable. Now, modeling type just means what do the measurements in that variable actually mean? So for instance, in the salary variable, we have numbers. And there's a little blue triangle next to that column. And if I click it, you'll notice that JMP shows me an indication of really what modeling type has been selected. It's currently selected to be continuous. Now what that means in JMP's mind is that those observations reflect a real scale. Those are numbers that mean something numeric, right? But imagine we had a column of ones and zeros. Those could mean numbers, but they could also mean categories if the ones and zeros stood for males and females. So JMP will be pretty smart about this. It'll assume you have continuous measurements if it sees numbers, but just be aware that it'll get it wrong if you use ones and zeros to measure something like gender. So I would suggest always use characters if you're entering in data about categories, and reserve your numbers for actual measurements. So things like years or time or distance, things that reflect true scales. Now, my point of bringing up modeling type was, again, that JMP knows what to do with these types of variables. So you didn't have to tell JMP to give you frequencies, not summary statistics. So the distribution platform is a very flexible platform. You can simply give it all your columns, and it will produce the right output. Now, before we leave the distribution platform, I want to remind you, if you haven't used JMP before, or remind you if you have and tell you if you haven't, that these little red triangles that you're going to see all over JMP, these are very, very special. So these are the context menus. These are menus in JMP that give you more options, but they give you more options in a special way. They give you those options that make sense in the context you're in. And so I remember I introduced the distribution platform almost like a room in a house. It's a place where a lot of tools live. And all of those tools relate to understanding distributions, or really the observations within a variable. So the red triangles under each of these different variables give you those options that make sense for a distributional analysis, but given the modeling type you're in. So let me sort of explain that in a different way. If we're in the birth year section, that's a numeric column. Those are actual numbers. This red triangle will give me all the options to go deeper in a context of numeric observations where we want to understand the distribution. So for many of you, this may be something like fitting a continuous distribution, which you can do in JMP. Certainly, we can fit ones that we expect, or we could even fit all of them to see which fits the best. Right? That's an option that makes sense given the context we're in. Another one you'll probably often want to do is a one-sample hypothesis test, so testing the mean of this column against some known hypothesis mean. So, for instance, if we observed, we did observe a mean of 1971 as the average birth year, presuming that we knew the population average birth year, maybe we could test to see if we had sampling bias. I mean, we may have known that in this population that we sent this survey to, the average year was actually 1968, let's say, was the average birth year. And so we want to know, maybe we biased our sample or have evidence that our sample is biased towards younger individuals that are more likely to return our survey. So that's a null hypothesis. When we click OK, this output gets produced below. And so just to remind you, if you have seen JMP before, or tell you if you haven't, when you produce analyses in JMP, they produce in the same window. And so I talked about the idea of flow before. This is a nice thing about JMP. As you produce output, let's say a normal quantile plot, all of the output stays right next to where you just were. So there's never any going backwards. You only go forwards. All right, so the red triangles are menus. Click these whenever you see them as you're first learning JMP. And I showed you the red triangle for the numeric column, and I mentioned that JMP is special in that it pays attention to the type of data you have. Let's look at the red triangle for single status. Notice that that is the same room. We're still in the distribution room, but the context has changed. These are categories. So the types of analyses we can run certainly are different. In this case, testing the proportions, or what we call testing the probabilities of falling into a particular level. So that's that one sample chi-square test. Right, so these red triangles are worth clicking. Every time you see them, definitely look at what's underneath them. All right, so that's the distribution platform. I would recommend as really your first step, when you first get your data set, put everything into the Y role and look at each variable one at a time, just to get a sense. And again, the way to do that, analyze distribution, take everything you want, click it into Y, and click OK. Remember, JMP is smart enough to know what to do with each column so you can mix and match types of data. Now, I said at the very start that probably the first thing you noticed about this platform, if you're new to it, is that the histograms are vertical. And I mentioned that these red triangles are little menus. Now, there's one upper level red triangle I want to familiarize you with, because that red triangle gives you options that apply to the rest of this output. And one option you may want to use is called stacking, because what stacking will do is rotate all the output such that we are now in a sort of a vertical scrolling orientation. And so that's what stacking means. Stacking means change the orientation I would scroll from left to right to top to bottom. And if that's your preference, then certainly go ahead and change that when you launch the distribution platform. Or if you always want that to happen, go to your preferences. On the Mac, it's under the jump menu. On the PC, it's under the file menu. Go to your preferences and set that as a default under the platforms section. Now, platforms, remember I said, are like rooms in JMP, and there's lots of rooms that hold different types of analyses. We were just in the distribution room, and what I was suggesting was if you always like distributions to be stacked, set it as a preference. That way, your JMP program will work the way you expect it to work or the way you want it to work. And I actually really love the customizability of the software in that way. All right, so that's distribution. That's a way to get a good sense of the data. Now, if really what you need is just pure summarizations of the data, I want to show you some ways to do tabulation. Now, the older way, the way that's still used in some cases, is using the tables summary function. Now, that's really an older platform. It uses a launch window. And what I mean by that is we simply specify the variables we want, and JMP will build us a summary table. So for instance, if I wanted to have some summarization of the average salary by people who are at different employee tenures, so 10 to 20 years, less than 5 years, more than 20 years, so I wanted some kind of table of their salaries. Let's see how we would make this. So employee tenure, that's really my grouping variable. I want to group the output or the table I make by the levels observed in employee tenure. So I'm going to click that into group. Now, the up and down here, this is which way you want it to be sorted. Do you want up lowest to highest or highest to lowest? So we can change that sorting. Now, we still have to define what statistic we would like to report here. And what we wanted was salary. So I'm going to select salary. And when I click this little red drop-down triangle, we get to select which statistic this table will create. Now notice we have to choose a statistic because we're summarizing over many observations within each level of employee tenure. We have lots of people between 10 and 20 years. So how do we want to operate on the observations? And that's what this is asking me. I think the most natural is probably the mean, but maybe we want the median or something else. So notice that you can select different options. I'm going to select the mean. Now before I click OK, I'm actually going to click Keep Dialog Open, because for me to show you a couple things, I want to keep this window around so I can show you the consequences of some of the changes we're going to do. You wouldn't have to click this, but I am going to click it right now. Okay, so I'm going to click Create, and I want you to see what JMP just did. It created a table, an actual JMP data table, that had as the levels, or the rows now, the levels of employee tenure. It gave me a column that told me how many observations fell into each one of those, and it reported the summary statistic I chose. Now let's keep this table here for a second, because if I wanted another summary statistic besides just the mean, notice that I can select it and add it to this table. So I can have mean and standard deviation. So when I click Create, I've created a separate table that has the additional columns. So that's what adding in additional columns here does. All right, so let me take that out because I want to show you a different thing we can do with this, which is the subgroup section. Because sometimes you don't want a table just like the one I have on top here, where you have mean and employee tenure. Maybe we want to break this apart in columns across some other level. Maybe across the people who are and are not working on their career. So let me show you what will happen. I'm going to click this into subgroup so you can see what the subgroup section does. When I click Create, what we get is a table with just the mean, because I only had the mean specified, but with disagree and agree as separate sections. So we can actually break out that table by subgroups. And you can nest as many of these grouping or subgrouping variables as you want. So that's the summary platform, which is a nice way to create tables. I think it's actually very fast, and once you're very used to it, it's nice. But let me take you over to tabulate, because I think you may like this for most operations. And then once you've made the table you want, maybe you'll go back to summary. Now tabulate, I went to it rather quickly, but it's under the Analyze menu. It used to be in JMP 10 and earlier under the Tables menu. But tabulate is drag and drop table creation. So let me actually create the tables I just made using summary, but now I'm going to do it using tabulate. And let me get back to my original table so that tabulate knows what data to use. So I'm going to go back to analyze tabulate. Now the table over here, remember what I had was I had rows defined by employee tenure, that variable, and a column defined by the mean of salary. So let's see if we can make this. Now with tabulate, these drop zones can accept columns that I drag. So the way to do this is to drag the columns that define the structure of the table you want. So my rows are defined by employee tenure. So let's grab employee tenure. I'm going to just drag it over here. Now I haven't dropped yet, but notice that the drop zone highlights when you are able to drop something. So if I drop it now, it defines the table interactively. We're not done yet, of course. We've just made the first little part of the table. But notice how easy that was. So let's work with salary. We still have to do something with that. If I drag salary, and in the middle here, right, that's where I want those data to be. So I drag the variable I want to summarize right into the end section there. What JMP will do immediately is choose a summary statistic. Remember, we're operating over multiple instances of the same category, so lots of individuals falling into each of these. So the summary statistic it chose as a default was the sum. It totaled everything. It's a reasonable thing to do, but we usually want the mean. So let me show you two different ways to change this. The first way is to grab a statistic, or even a couple statistics on the left. So grab one of them and drag it and drop it right on top of sum. And in JMP's mind, the operation when you drop on top of something else is to replace. So when I drop it, notice it replaced the mean. Let me click undo, because I want to show you a different way to change this. So you can also right-click the summary statistic and notice that there's a whole selection, so a drop-down of all the options that I had over there on the left. So I can change it to the mean right there. Now, I prefer to drag, and let me show you why I prefer to drag, because when you drag, remember you can always drop on top of something else. That will replace it. But I want you to focus your attention on my mouse, because look at the drop zone, and look how small it is to the left and to the right. There's a special drop zone. It's not just the replace action. This is actually the appending and prepending drop zone. So I can prepend or append another summary statistic. And that idea of being able to take a variable and append or prepend works all over tabulate. So for instance, remember I wanted to make a table that had I'm working on my career, breaking up sections. So let me take this. Instead of dropping on top of something, let me just drop it above. And notice what it does is it adds that variable into the little section there, so it's breaking it up. Let me show you another way of doing that. I'm going to drag it out. Notice you can just move things around. If I were to drop it on top of employee tenure, that would replace it. But remember, I can go to the left or to the right. So let me go to the right. And notice it builds me a little table with career nested inside of tenure. And I could switch it. I could drag it now to the left of employee tenure and switch the nesting. Right, so this is a great use of tabulate. You can actually build these tables interactively and play around with them to see what really shows whatever tabulation you want to do. Now, you can customize this output. One thing I like to do is get rid of the 13 decimal places or whatever. So click Change Format. This is a nice way to do it. And personally, whenever I'm working with decimals, usually I want to have the same format for each of the different variables. And so I like to click Use the same format. And then I'll say something like fixed decimal with, let's just do 2 decimal places. And I'll click OK. And so that makes my table look a little bit prettier beyond what it was with 16 decimal places. Now, the other thing I like to do, certainly once you're done with this output, you can click the Done button. That will close the control panel. And this is a little table that you can actually interact with. Remember that everything in JMP is interactive. And so when you click on these different observations, let's say the less than 5-year mean, it'll highlight the 47 individuals who counted in that less than 5-year disagreeing category. And so this is actually kind of cool. It's a little interactive table that lets you find observations. But there are times when you need to operate on this tabulation as if it was a real data table. Remember, summary made a real data table. This is a tabulation. So to make this a real data table, and you should remember this from what I said earlier, click every red triangle when you're looking for options. So that red triangle has the option to make into data table. And what that means is make this tabulation into a proper data table like you would have had you used summary. And so that will create a table, which is very handy. Sometimes you need to actually perform further analysis on your tabulation. And so remember, look for those red triangles whenever you see them. That'll give you more options to dig deeper. All right, so that's tabulation, a great way to make your summary tables and usually get to quick insights if really what you need is just a quick summary of the totals or averages or something across the levels of certain variables. Now, for me, really my first step with any new data set is distribution, maybe some tabulations, but I very quickly get into what I would think of as exploratory graphing, exploratory data analysis using graphing. And the best platform in JMP, the best way to do this in JMP is using the graph builder. And the graph builder lives under the graph menu. So it's not, under analysis, it's not under tables, it really is a graphing platform. And if you haven't seen graph builder before, it's special in JMP, very much like Tabulate is special, because it's built around this drag and drop interface to creating instead of what distribution and some of the other platforms we're going to see are built around, which is you start off by selecting your variables and then going into a platform. Instead, Graph Builder, just like Tabulate, you have access to every variable in your data set. It's on the panel to the left. And what you have are drop zones that let you create visualizations on the basis of really the variables you use in the different roles. And just to give you an orientation to this, the Y and X role are really your data roles. That's your Y variable and your X variable. The grouping sections are really when you want to trellis or break apart your graph into separate sections. And overlay and color and size really operate on whatever visual you've created by adding distinctions that really break apart the analysis using overlay, color things differently using the color variable, or size things differently using the size variable. So as ways to identify additional dimensions in your data. And so let's actually look at how this will work. Let's try some simple ones, actually. I'll start off with defining a X variable. And maybe I'm interested in how employee tenure relates to things. So I'll take employee tenure, and I'm going to drop it on the X. And notice as I hover even, JMP shows you the visual immediately, so you get a nice way of playing with the visualizations. Now, before I define a Y variable, let's take a moment to look at what JMP did. It created us, it's really a dot plot, but these points are just jittered randomly, and jittering just means spread or placed randomly. So what we get are little clouds, and the only value here is really to see the number of points. We can see there are more people in the less than 5 year category than the more than 20 years. But we don't get much else with this. But even so, notice the ribbon at this top gives us some additional visualization options. And that's what this ribbon really is about. How would you like to visualize what you've just defined in the lower section? And there are ways we can do it other than this. We could do a pie chart. Really never make a pie chart is our advice. But if you needed to, you only need one variable, and you could do it based on counts. We could have a very simple histogram. So really a frequency distribution plot showing us the number of individuals in each of these. Or even something like a tree plot, a tree map, showing us in terms of share. Right, so there are different ways of showing what is really low-dimensional data, just the number of observations in each section. And so that's what the ribbon does. It lets you select a visualization. All right, let's actually get more interesting, though. Let's pick a Y variable. And we were playing with salary before. So let's actually use salary. I'm going to drag it over here to the Y section. And notice what JMP did. It actually put these points now in vertical space in the Y dimension into their appropriate location. So the Y height for each one of these points is their salary. Now we're still using dots, and this may seem strange to people. Again, you get a sense of the distribution, but normally we're used to seeing means or box plots or other kinds of representations like that. So let's try to get one of those. Let's start with the bars. I'm going to click the bars. And notice what JMP does is it switches the visual. Our axis starts at 0, and we have a section on the left which gives us additional options for how we want the bars to look and how we want them to operate. We could add reflections of error around the bars, like confidence intervals or standard error bars. We can label the bars. We could even choose a different summary statistic. Notice that we are operating on the individuals in each of these different sections. So maybe we don't want the mean, but would rather have the sum, so the total salary of all the individuals falling into those groups. There are reasons maybe we want to know this. So notice that you have the options on the left to change what the bars are doing. Now let's go along the top because there are different ways we can represent this. We can do an area plot. We can do box plots. Box plots we really like. They tell a lot about the data. Certainly a reflection of the central points. So we get the medians and we get the outer and lower quantiles and the fences. Now the points that are beyond the fence here, so this is a reflection of how outlying a point is. And Tukey had this as 1.5 times the inner quartile range. So that's the distance from this point to this point. 1.5 times that plus the point where my mouse is at here. So that's what defines this outer fence. So how far can you really be from the median before it's strange that your point is that far? So somebody who worked for less than 5 years and is up here at 150,000, basically this sort of outlier test says that's pretty strange to be that far. So I like box plots for that reason. Now you may have noticed something when I select points. Just like everything else in JMP, when you select observations, they're selected everywhere. So even in the data set, those 11 observations are selected. Now the value of this, just thinking about your own understanding of your data, is once you've found points that maybe are suspicious, you can operate on them rather quickly. So we can go back to the data table, we can right-click the row, and we can exclude them if we want. So you can remove them from further analysis. That's one thing you can do. You can give them their own markers, so a way to define whether they're strange. So you can actually give them a marker. So if we look in Graph Builder, they're marked. There's lots of things you can do with them. I'll show you one of my favorites. So once you select them, you can right-click. Notice the rows menu in Graph Builder is the same thing as the rows menu when I clicked the row in the data table. My favorite thing to do is this option, Name, Selection, and Column. Because what this does, and I'll sort of give you the premise for this. When I look through data, I try to find data that maybe doesn't fit the pattern or things that I want to investigate further. And I find lots of different things that are interesting for different reasons. So these may be interesting on the basis of some particular reason. So I want to name this selection something. And so it's interesting for reason, A is why this thing is interesting. And I want the ones I have selected to have a 1 in my data set and the unselected ones to have a 0. And so what I mean by that is now I get a new column in my data table where it actually identifies those individuals. And so I could have overlapping or completely contradictory sets of individuals I have selected, but I can save those selection columns so I can very easily reselect those individuals. And so to give you a sense of, or show you that again, points that are weird or anything you want to select, just grab them, right-click. There's going to be a rows menu. And the rows menu gives you all the operations for the rows. So you can exclude, hide, label. The one I used was name, selection, and column. And so I find that to be very useful. All right, so notice that Graph Builder gives you the ability to really pick a visual from this ribbon that makes sense given whatever you're looking at. And we find this to be a really great way to build graphs because your data doesn't define or your design doesn't necessarily define what graph makes sense. Your graph is meant to tell a story about your data set. And you need to know what that story is often before you tell the story. And so graphing is not only useful to learn what the story is of your data, but to make really the most effective way to convey it. And we really suggest that whenever you're creating a visual, certainly make the one that you thought you wanted to make first, but try some other ones. See if there's other ways of telling the story that make the point very forcefully. All right, so before we leave Graph Builder, I want to show you some of these other roles because they let you do some pretty amazing things with Graph Builder. You can get pretty fancy with your visualizations. So for instance, we were playing with this idea of whether somebody was still working on their career. And this variable can be used in a lot of different ways in this graph. I mean, so far we're looking at salary based on employee tenure. But let's see how we might be able to further break apart this relationship. So as I start to drag this, notice that the drop zones that are available to be used are all highlighted. And so I'm going to drag it without dropping to some different places. First, I'm going to drag it to group for X. And I want you to notice what JMP did. Is it split up my x-axis into two sections. On the left, I have all the individuals who agreed that they're still working on their career. And on the right, I have all the people who disagreed. And I have the box plot still broken apart by employee tenure. So take a second to think, if this were the visual I were using, the most perceptually accessible comparisons are really between employee tenure amounts within a particular level of career achievement. So whether somebody is agreeing or disagreeing. And what I mean by that is the comparisons are very perceptually easy to make here on the left-hand side and here on the right. But if I ask you, is somebody who's working 10 to 20 years who agreed versus disagreed, do they differ? And you have to look across all these other bars. Notice that's actually perceptually kind of hard. And so be aware of what you're making easy and hard to recover about your data. If you really want to make it obvious that agree versus disagree is different or the same for 10 versus 20 years, you need to switch those variables. And I want to show you a trick, and this is really handy when you're making different visuals. Right-click a variable, and notice there's the option to swap. You can swap a variable in this analysis with something else. Let's swap it with employee tenure. So I'm changing out career for tenure as variables. And notice that this is a very different visual. It has the same number of bars, but we've made perceptually accessible the things that we were most interested in, presumably. So if I wanted to really show off this 10 to 20 year comparison between agree and disagree, this makes more sense. This is easy to make that comparison. So be aware of what you're making easy and hard, and there will be trade-offs with any kind of visual. All right, so let me swap those back again, or I'll just click the undo button. Because what I want to do is take this agree-disagree variable, I'm just going to drag it out, and let's move it to some different places. So I want to show you what happens if I hover it over group for Y. Notice what that does. Group for Y breaks apart the Y-axis, which makes it actually really perceptually difficult to make comparisons between agree and disagree. Right? So if I want to look at here versus here, I have to actually go over to the axis. So that's made perceptually hard. But notice why that's valuable. There may be times where these are completely incomparable. So people who agree and disagree, it's not even sensible to compare the 10 to 20 year ranges between those two. So if you don't want people making the comparison because it's silly or not sensible, you know, that's a fine way to do it. Make it hard if it makes sense to not encourage it. And so think about these roles as a way of discouraging certain comparisons as well. All right, so that's group for Y. I want to show you another one, though, which is overlay. Because overlay is doing something kind of similar to what we did before. It's a different way of making this happen. And notice that, let me give you the direct comparison. So here was group for X. So that's where, remember, we split apart agree and disagree as part of the axis. And so, you know, if it were comparisons between those two, it would be hard to make. Look what happens when I use that same variable as an overlay. What it did was give me separate box plots right next to each other for the agree and disagree levels. So in essence, we just accomplished the same thing, but we're not doing it on the basis of splitting up the axis. We're doing it on the basis of really a coded or a coloring of these different bars. And so for box plots, that's the way it renders it. I'll just do a bar chart so it's very obvious. So with a bar chart, what that overlay is really doing is it says double the bars. Give me a bar for each of the levels of whatever this variable is. Whereas the group for X section says, give me separate bars, but spread them out. Do them in separate sections. And so you may have some luck using overlay in a way that the grouping variables won't be useful for you. So definitely play with overlay. Now the last one I want to show you is wrapping. And to show you that, I'm going to use a variable that has more levels. So job satisfaction is a good example. So notice that if I use something like job satisfaction on the split for X, we have 3 sections, which isn't so many. But if I do wrap, look what wrap does. We still have 3 sections, but it will wrap from left to right. And this is kind of cool, because when you have variables with lots of levels, this becomes a nice way to see them, this kind of trellising of the plot. And so that's what the wrapping does. Wrapping is just like group for X or group for Y, except it wraps left to right and then top to bottom. Now, just so you know, with any of these grouping variables, so group X, group Y, or wrap, so those group sections, all of those, you can right-click the header bar and you can change things. So you can change whether the title is shown, the color, where the group edge is, but this is the important one, so the number of levels in view. There may be times you have a grouping variable with hundreds of levels and you don't want to see all 100. If you select fewer than the total amount, let's say 1 at a time, you get a little toggle. So you can actually toggle through the levels of that variable. And I mention this because this is a great way to, when you're showing data live, click through different levels of variables. So again, the way I did that was you right-click. Once you've used a group for X or Y or wrap, you right-click the header bar and go to Levels in View. And so just change it to anything less than the total number. And so I'll put it back to all, and you'll see we'll see everything. All right, so that's Graph Builder, a great way to visually summarize very quickly your data and see what's really happening in your data set. And I think it's probably a good thing to do all of these things, even though they're not the most sophisticated analyses, to do these things before analyzing your data, because it's nothing worse than going through the routine of all these analyses without discovering the outliers or that you have miscoded categories. So certainly take advantage of the tools in JMP that make that quick. Now, with that sort of backdrop, let's look at some of these analyses. And like we've done with the other platforms, what I want to do is sort of show you through each of them and point out the important features. Now, first, starting with regression. So regression really breaks itself into simple and multiple regression, but the context is really the same for both of these. What we're really interested in is among numeric variables, is there some relationship that we can model? So with a line, with a curve, in some ways, there's something between numeric variables that identifies how much of y you should have based on what level of x you have. And simple and multiple regression only differ in terms of how many things you're using to predict that y or that outcome. So if it's one variable, it's simple regression. If it's multiple variables, it's multiple regression. So let's start with simple regression. So again, the context is one y variable that's continuous. By that I mean numeric, like salary, years in current position. And we have an x variable that's also continuous. And we're going to look at two different platforms, two different rooms in JMP that allow you to do this type of analysis. The first is fit y by x, and the second is fit model. Now, before we get into using either of those, let's actually use Graph Builder as a way to think about what we're going to be doing. And so again, we said we're going to have two continuous variables. So that's all the blue triangle ones. Just to make it very clear, I'm going to go to this red triangle, and I'm going to say, don't show me anything that's character. Only show me, or let me do it this way, don't show me anything nominal and uncheck ordinal. So only show me continuous variables. So these are the only ones in our data set that really will make sense for simple regression. And so what I want to do is I want to look at salary. I think that's an interesting variable to look at. And let's see how salary relates to some of these things. How about age in years? All right, so I'm going to drag it to the x. So in essence, we're going to want to fit a line, or we're going to do regression between these two variables. Now, the way the JMP is shown in Graph Builder is this smoother. To give you a sense of where we're going, I'm going to click on this line of fit. And so this is what we eventually want to understand. We want to make this line. We want JMP to tell us, what is this line of fit, the regression between salary and age in years? All right, so I told you there's two platforms in JMP to do this analysis, fit y by x and fit model. Let's start with fit y by x. So under the Analyze menu, fit y by x. Now, fit y by x is just like distribution, a big platform. It's a big room in a house. It's really a collection of rooms that lets you do related analyses. And the way it works is fit y by x is good anytime you have one y variable and one x variable. In this case, we do have one y and one x. It happens to be that both of them are numeric. And so this fit y by x platform will know what to do with those data when you have a continuous variable, a numeric data on the x variable, and a numeric piece of data on the y, right? That's this bivariate room within the fit y by x platform. All right, so we did it in Graph Builder. Let's see how we're going to do it in fit y by x. We're taking salary. That's our y, so I'll click it into y. And we're predicting that on the basis of age in years. Just so you can see a different way of doing this, I'm going to drag age in years over here. I'll just drop it there. Now let me click OK. And the first thing JMP does is makes a scatter plot, just like we made in Graph Builder. Right? We don't have a line yet, and we actually don't have anything else. This is a pretty absent or a pretty empty output, actually. We have our scatter plot, but that's about it. Remember, red triangles take you further. Every time you see a red triangle, when you're first learning JMP, I want you to click it and sort of come to expect what you should get underneath it. So before I click it, let's expect what we're going to get. We're in the bivariate room of fit y by x, a room that's about relationships. We have two numeric columns. We're calling them continuous. That means numeric data that actually means numbers. And this red triangle will show us options that make sense for analysis of these two variables. Well, we should hope that we can see fitting a line. We were able to do that in Graph Builder, but there's probably other things we can do. Well, let's take a look. So fitting a line is one of the first options there. Fitting a polynomial, so we can do our quadratic regressions, our quartics. Fitting special does transformations of the variables or other special things. Flexible fits like splines. Orthogonal fits, robust fits. Right? These are all sensible things to do when you have two numeric variables. So let's fit a line. That's the simple linear regression we were looking for. Now, when you fit a line and jump, you get a typical output. You get your representation of the relationship. And so this is the actual equation for that line. So we have our y-intercept. How much of x do we have when we have 0, or how much of y do we have when we have 0 of x, plus the slope. How much increase in y do you get for a 1 unit increase in x? Remember, in x here, we're talking about age in years. So this is how much more in dollars do we expect a person to get on average when you have 1 more year of age? And it's $472 is the average trajectory here. All right, let's look at the rest of our output before we go on. So we have a summary of fit table with an r squared. So this is the coefficient of determination, what proportion of variance in y is determinable through the relationship, the linear relationship with x. R squared adjusted, this adjusts for the number of parameters. Root mean squared error, our mean of response and observations. Remember, these gray triangles lets you hide and show things. I actually like to, when I'm going through an analysis, hide the observations or the output that I've already looked through, just so I can keep the window all in one screen. Lack of fit, I'll skip for now. Analysis of variance table you will always get with linear models. So this will be testing the full model versus the simplest model, predicting just the mean of the response for everybody. And so you'll get the model and error terms. So your analysis of variance table in this case will actually be identical to your test of the slope. That's true only for simple regression. But probably the most important part, if you're doing simple regression, will be the parameter estimate section. So the intercept, this is the value that corresponds to how much of y do you have when you have 0 of x. So you'll get an estimate, you get the standard error of the estimate, you get the t-ratio, and the p-value. And the p-value here is the two-tailed p-value for the intercept and for the slope. So this is the estimate of the slope in this relationship. Just so you know in JMP, these tables, you can right-click, and almost always there'll be a section called columns that gives you additional options. And so this is where you're going to find things like the confidence intervals for the parameter estimates you can turn on. The standardized beta is one that a lot of people look for. So this is if you were to standardize your variable z-score them before regressing y onto x, what would the coefficient be? So this is equivalent to the correlation coefficient in simple regression. So again, right-click a table and go to columns, and you'll notice you get that option to really change and add different things. Now remember, you always get more options, so click every red triangle you see. The red triangle in simple linear regression in fit y by x includes some really important options. One that I really want to point you to is plotting the residuals. So whenever you fit linear models or whenever you fit regression models, looking at the residuals is a nice way to make sure that the model assumptions you've made are really are reasonable. And so this will give you what's known, we call it the residual bundle, a bundle of plots. And so under that red triangle, make sure you know that that is an option. You can also save the residuals and save the predicteds. This will save a new column to your data set, which allows you to look through them in a little more detail. All right, so quickly, just so you see the correspondence, let's keep this window open. I'm going to go to a different room, a different platform that is also able to perform simple linear regression. And that's under the Analyze menu, and it's called Fit Model. And the reason I wanted to show you the two of these is really Fit Model is like the big brother to Fit Y by X. It will do everything Fit Y by X does and a bunch more. But there are some special affordances of Fit Y by X, which is why we still have it. But just so you see that Fit Model can even do the simple things, let's set this up just like we did for Fit Y by X. We had a Y variable, it was salary. As soon as you click in a Y variable, JMP will set the personality of this Fit Model platform. If it's continuous, it'll assume it's standard least squares. Don't worry too much about that right now. Just know that the Fit Model platform is very general. It can handle lots of different types of data. So salary is my Y. The X variable, in this case, we only had one, and that was age in years. And so the only difference in Fit Model is you have a construct model effects section. This allows you to do more complicated things. But for us, we'll just click add. This is actually a very simple model. It's just one Y and one X. So when I click run, notice that the output will look a little different. It's a different platform, but we have familiar sections, a summary of fit table, which will have the same values, an analysis of variance table, which will have the same values. I'll just hide actually most of these except for, let's look at the parameter estimates, and just so we can confirm for ourselves that they are identical, there are all the terms. And just like the trick I showed you before, right-click a table and go to columns if you want to turn on different things. So in this case, we'll turn on the standardized beta as well. And so we want to see that standardized version. The only reason to use fit model, however, or one of the best reasons, is under the red triangle, there are lots more options. So in fit y by x, you are a little bit limited, whereas fit model, we can save plenty of additional things beyond just the residuals and predicted. So influence and leverage pairs, hats if you want to do additional analysis on influence, lots of things there. And one very, very nice thing that I love about fit model, which is under factor profiling, this option called the profiler. And the profiler is really neat because what this is literally is a prediction profiler where you can, what we call dialing in or just dragging this little slider around to set a certain age in years, and you'll get the confidence interval about the prediction, or sorry, excuse me, about the mean response for the variable. The nice thing about this, though, is it really lets you see the model and click through the model. And for more complicated models with interactions or for other terms, the prediction profiler is really the best way to make sense of what's happening. But again, for this section, just note that fit y by x and fit model returned really the same output. And for simple regression, the only difference between the two is really your platform of choice. You'll get additional options in fit model, but fit y by x may be the faster way to run it. All right, so that was simple regression. Just so you see, for multiple regression, we can't use fit y by x. And I'll just show you very quickly in fit y by x, really the consequence of setting something up that may look like a multiple regression. So for instance, predicting salary, what if we predicted salary on the basis of age and years? That was what we did before. But we thought, hey, let's put another variable in here. I'll take years at current employer and click it into the x variable as well. You might think that JMP will use both of those variables to predict salary, and in a way it will, but it will separately. That is, in the same window, you will get two separate bivariate outputs, one on the left predicting with age and years, and the other predicting by current employer. Now, this is actually one of a great use of fit y by x. Notice that we can have an arbitrarily large number of analyses that all live in the same window. I wanted to show you something, though. If I go to the red triangle and select fit line, that's what you would naturally do if you wanted a line, we only get a line for the left-hand bivariate fit. So JMP only did it once. Let me actually go and remove that because I want to show you a trick, and this is actually one of them under my tools here. This is called broadcasting commands, because this is a very important thing to be able to do in JMP. What if we had, let's not say 2, what if we had 1,000 different analyses in this one window? So it went to the right-hand side 1,000 levels. So not just age and years and current employer, but 998 different variables. If I wanted to fit a line for each of them, I don't want to have to click each red triangle. And so the way to do that in JMP is to hold down, if you're on the Mac, hold down Command, select the red triangle, select fit line, and then let go of Command. If you're on the PC, you'll do the exact same thing, but hold down the Control key. So the way it works is, again, hold down the Control key, or Command if you're on the Mac, click the red triangle, select what you want, and once it's selected, let go. So Control on the PC and Command on the Mac. Now the benefit is this works all across the platform. So for instance, I'm going to hold down the Command key, and I'm going to resize this graph. And notice it resizes both graphs. If I'm not holding down the Command key, I can resize them separately, right? But as soon as I'm holding down the Command key, whatever I do broadcasts, even closing things. So if I hide sections while holding the Command key, it'll hide it as well. So the benefit is that you can operate on these outputs all at the same time. So if you had 1,000 analyses, you could have run 1,000 regressions in the same amount of time it took to run one, in essence. So remember that broadcasting commands trick. Whenever you have multiple output in the same window, you can operate on it using the same actions, as long as you're holding down Command or Control if you're on the PC. All right, so we can't do multiple regression in fit y by x. That's what I was mostly just showing you in that case. If we want to do multiple regression, we have to do it in fit model. And so let me go to the Analyze menu and show you that one rather quickly. So we were predicting before salary, and we were before predicting it on the basis of just one variable, age and years, and I had clicked Add to add that to my model effects. Now, for a multiple regression, we need multiple variables in the model effect section. And one that might be reasonable is something like years at current employer. I mean, we saw that there was a relationship between salary and age and years, but what we really might want to know is, For people who are the same age, would it be a difference in their salary based on the number of years they've been there? Or said differently, for somebody who is at their employer for the same number of years, is there some effect of age? Can we show that there's an effect of just being older, that it has nothing to do with how long you've been at your employer? That's the magic of multiple regression, to do a partial regression coefficient. What's the effect of one variable holding constant the other variable? So the way to do this, we'll click Add, and we'll have both of these variables in the Model Effects section. Now, unlike fit y by x, we won't get two separate regressions. Instead, we get a single regression that has both variables as parameters. Now, I'm going to hide some of the output here, because let's just take a second to look at our parameter estimates. Because what this is showing us is, again, this is a difference between simple and multiple regression. What is the effect of an additional age in year, so one more year of age, assuming that your number of years at your current employer isn't changing? So for people who have been at their employer for, let's say, 10 years, is there a difference between somebody who's 51 versus 50? And that's that estimate, holding constant years at employer. And what's kind of neat about this is, look at this. We found evidence that years at employer really matters. But when you have a model with both of them, your age actually doesn't seem to matter. It's not that being older helps you get higher salary. It's that being at an employer longer helps you get a better salary. Now, like I told you before, when you have linear models in Fit Model, go to the Factor Profiler and turn on the Profiler, because this lets you actually click through this model and drag in the different levels. So you can actually see, if you're at your employer for 20, let's say years, right around 20, and your age is 51, what should your expected salary be? That's a way of really playing with the prediction. Now, if you're teaching multiple regression, and this is probably where I'll have to end before I take questions, I would absolutely suggest going to Factor Profiling and turning on the Surface Profiler. So for simple regression, it's a pretty straightforward case. You're fitting a line to data. With multiple regression, it's a plane. And being able to see the plane, what I'm going to do is click on the actual points here. So this is the multiple regression response plane. And what's beautiful about showing the plane is it's actually a nice way to, look whether your model is really behaving well. In this case, I'm not really very happy about where those points are relative to the plane. They're all kind of in a rarefied dimension there. But it's a nice way of actually seeing what the model is that this data is actually allowing us to see. And so that's, again, under the red triangle, Factor Profiling, and the Surface Profiler. All right, so Fit Model. Again, when you have multiple regression, more than one predictor, you need to have the Fit Model platform because it allows you to construct that model effects. All right, so we didn't get to test on means or contingency, but I want to point before I take questions the resources again, because if you're looking for procedural knowledge, the user community that we built here for all of our academics really has a lot of great stuff we've tried to surface for you. So under the collection for one-page guides, I really suggest looking there for lots of procedural knowledge and videos and PDFs, and certainly if you have suggestions for ones you want, we're always welcome to hear them. But I think it's probably good to pause and see if Mia has any questions from anyone. And